Okay, this video is for exercise number 3 of experiment number 7. It's going to be a short video, but just to kind of illustrate what the difference in the experimental setup between exercises 1 and 2 and exercise 3. In exercise 3, you're going to have a microphone connected to the input to the anti-aliasing filter. And again, the purpose is for you to be able to, in this exercise, is to determine the frequency at which you whistle. Just to highlight again what you're going to need to do, you take the microphone, put it to the side of your mouth and whistle. Do not put it in front of your mouth due to the fact that if you blow into the microphone, you're going to pick up also basically the airflow into the microphone as well as your whistling. So you just want to put it to the side of your mouth so that all you're picking up is the whistling. If you can't whistle, a tuning fork will be provided for you, and you'll do the same thing, determine the resonant frequency of the tuning fork. As far as settings are concerned, again, you have two different types of gain settings here. You have, this is basically the fine adjustment and the coarse adjustment. And what you're going to need to do is first off set your filter to out. We're going to figure out a gain setting that amplifies the signal being recorded. So if you can see right now, if I start whistling or even talking into the microphone, you can see the overload light starting to flicker. That means that right now my gain settings are set to a point that is just starting to overload the signal. And that's what you want, because what it does, see if I turn it down 1, it actually it doesn't overload, but here it does barely. What it does when you overload is that it allows you to amplify the signal up to the point of almost saturation, and that allows you to collect a signal that's going to fill the range of amplitude that the amplitude range that this system can handle. So make sure that you get a good clear system so it amplifies the sound near the microphone and thereby minimizing the noise in the room, because it amplifies the signal that's closest to the microphone. So you're going to do that, figure out what amplification to set it to, turn your filter to on, and then you're just going to have to collect data several times at different cutoff frequencies. So since you don't know what you whistle at, you can try maybe starting at a certain cutoff frequency value, use that cutoff frequency to determine your minimum sample rate, collect your data on a Logger Pro, run an FFT on it, see if you get a signal a frequency spike. If you don't, increase the frequency maybe by another 500 hertz to 1,000 hertz, readjust your sample rate accordingly, and collect your signal. Again, if you don't get a spike on an FFT analysis at that point, raise it another 500 hertz to 1,500, which is 1.5 kilohertz here. Reset your sample rate accordingly, collect the data, run an FFT analysis, see if you get a spike. So basically what you're doing is that you're increasing the bandwidth that you're recording until you finally get a signal response by looking at the frequency spike on your FFT plot. I hope this is clear. Again, I'll be in the classroom to help you through this, but this is just meant to give you an idea of what you're getting into before you come. So this concludes video for exercise number 3 of experiment 7.